Howdy! This is your friendly neighborhood physics teacher here, and my last video, apparently it got cut short. Don't you just love technology? So I'm going to redo 16 and 17 for you so you can see the full effect of every question on the review. So on 16, Miss Verona's brother was going on a fishing trip. His journey starts at mile marker 75 miles. So that is a placement. That is his initial position. So 25 mile marker, that is his initial position. Says he travels 225 miles in 2 hours. So he's traveling 225 miles, and he's doing that in 2 hours. Before he realized he didn't have an updated fishing license. He had to return to mile marker 25. So he had to go back to mile marker 25. Where the Walmart was, and it took him 4 hours. So he went from here all the way back to mile marker 25, and they said that took him 4 hours. We're trying to find his total distance, total displacement, his speed, and his velocity. So this is where he ended, so that is his final position. So let's see which mile marker he was at after he went the 25 miles. So where he was at after the 25 miles. So he started at 75 miles. He went 225 miles. So we're going to add those together. 7, 8, 9, 10. So he ends up at mile marker 300. So this is a mile marker. Mile marker. So that's telling his placement, mile marker. So he ended up at mile marker 300. So now we can figure out how far he went back, because this way he's going this way, this one he's going this way. So now we can figure out how far he went back. So he started at mile marker 300, he ended up at 25. So if we subtract that, carry that, 9, 8, 7. So he ended up traveling 275 miles that way in 4 miles. Now we can figure out total distance, total displacement, speed, and velocity. We have everything we need now. We just had to do those 2 extra little things so we can get all the evidence we need. So the first thing we can do is find our total distance. So you know that total distance is 1 d1 plus d2. We can add it up. So d1 is 225, d2 is 275, and that's just the distance we traveled. So total distance is just adding up our total distance. It doesn't matter which direction. We don't worry about negatives. We just add them up. So we add that up. We end up getting 7, 8, 9, 10. 1, 2, 3, 4, 5. We ended up that he traveled a full 500 miles. He traveled a full 500 miles. That is his total distance. Now we're looking for displacement. So displacement, your equation for displacement is delta x equals your final minus your initial. So this is what these come over here. We have final, we have initial. So our final was 25. Our initial was 75. We subtract those. We end up getting a negative negative 50 miles. So our displacement is negative 50 miles, which makes sense because it's just that. And it's negative because we're going to the left. Distance, no direction. Displacement, direction. Yay! So now we need to find our speed. So our speed equation is our distance over time. So our total distance was 500. What's our total time? So total time, we traveled 2 and then 4, so that means our total time is 6. So now we just do 500 divided by 6, and you get, pull out your handy dandy calculator here, and you get 83.33 continuous miles per hour. So that is your speed. Your velocity, your equation for velocity is your change in displacement, or your displacement over total time. So our displacement is 50, our time is still 6. So we do the math for that. So you do negative 50 divided by 6, and you get negative 8.33 continuous miles per hour. Direction matters for velocity. Direction does not matter for speed. So that's why it's called a speeding ticket and not a velocity ticket. Chunk. So there we go. There's 16. 17. A ball is dropped off a very tall canyon ledge. Gravity accelerates the ball at 9.8. Technically, it's negative 9.8. Should be a negative 9.8. How fast is the ball traveling after 5 seconds, and how far did it fall? So let's do our givens. What are our givens? So we know that the acceleration is negative 9.8 meters per second squared. And we have time, which is 5 seconds. Says the object is dropped. That dropped is letting you know that our initial velocity is 0 meters per second. Our unknown, we're looking for how fast, so we're looking for the final velocity, and we want to know how far, so we're looking for displacement. So the equation we'll end up using, our equation has to have final velocity in it. So if there's an equation that does not have final velocity in it, we can cross out, which is this one. This one does not have final velocity in it. But we don't have distance just quite yet. That's something we're looking for. So we can't use these two because it has distance. So we have to use our third equation. Our third equation is VF equals VI plus AT. Now we're substituting. We're looking for our final velocity. Our initial velocity is 0. Our acceleration is negative 9.8. And our time is 5. So our final velocity ends up being negative 9.8 times 5, which gives you a negative 49 meters per second. So that is our final velocity. The next thing we're looking for is displacement. So our final velocity is no longer an unknown. We know it. It is negative 49 meters per second. So the only unknown we have now is displacement. So let's look at our equations. That are up here. So let's look at our equations. This one does not have displacement, so we can't use it. But we can almost use any other one. Now, I'm going to remind you with caution. You found final velocity. There is a slight chance on your test that you might have gotten part A wrong. So let's not use what you used on part A. Let's see if we can do it without part A. So we need to do it without final velocity. So that has final velocity. That has final velocity. So now let's use the first equation because it does not have final velocity. Even though we have it because we solved for it, but we're not going to use it just in case we got it wrong. I'm going to let you know I didn't get it wrong, but I'm letting monologue thinking while you're doing your test, what you should be thinking. So we're going to use the first equation. We're looking for the displacement. Our initial velocity is 0. Our time is 5. Our acceleration is negative 9.8. Our time is 5 seconds. Anything 0 times anything is 0. Make sure you do your exponent first. So 5 squared gives you 25. And now you can just straight multiply. You would just multiply 1/2 times negative 9.8 times 25, and you get a negative 225 meters. It's negative because it's going down. It's negative because it's going down. And there we go. So there we go for the last 2 questions on your review. Again, if you have any questions, please let me know. And I hope you have a wonderful day. Happy studying. Bye.